este ratito a la presentación.
Hello, welcome to this new virtual tour of the European Southern Observatory, or simple ESO. It's an acronym. My name is Hernan Julio, and with the producer Farid Char, we're going to be your guides during this trip to the ESO Paranal Observatory. Just a little bit about me. My name is Hernan Julio, as I told you, and I'm a journalist specialized in astronomy, and I've been working the Chilean Observatory and ESO for the last 20 years. So welcome, and I hope you enjoyed this tour today. Please remember that you can send your question and comments during all this streaming. And I can imagine you already have several questions. You can leave your comments in the comment section of this broadcast on Facebook or YouTube. And also, if you are live, please, you can send your question and we will be very, very, very happy to answer you. Okay? From anywhere you are in the world, you are welcome. And today is a very special day, very special occasion, and a very special tour too, because we have also Dr. Eleonora Sani. And I want to welcome her. She joined ESO as a staff astronomer in March 2015. Eleonora's scientific research focuses on the evolution and physical connection of supermassive black holes and their host galaxies. At Paranal, Eleonora operates several instruments and facilities, including the interferometer. She's in charge of the training protocol and chair of the instrument operation team. So I welcome Eleonora, and also remember that you can make all the questions from her. Eleonora, good morning. How are you? Welcome.
I'm fine, thank you. Welcome everybody, and thanks for inviting me to this event, Hernan.
Well, thank you. Remember that you can, we have Eleonora, and you can make all your questions to her, to a real astronomer right here in Chile that works at the most advanced telescope in the world, which is the VLT in Paranal. Also, of course, I would like to introduce Emilio Girardin, Trade Advisor Pro Chile, UAE, Head of Protocol Chile in the pavilion of Expo 2020 Dubai. Hello.
Hi, everyone. Here we are at Chile Pavilion in Expo 2020 Dubai. We'll be taking questions from the public here. So more than happy to participate. Thank you for the invitation, and we are really looking forward to this presentation. Thank you again.
Well, great. So I guess we're ready to start this tour. First of all, we want to help you to understand the place of our visit, okay? So we're going to give you some information about the European Southern Observatory, ESO. We have an image of that is in the screen right now, and you can see the headquarters of ESO are located in Germany. Also, Australia has recently joined ESO as a strategic partner. Chile is the host state and a home of all ESO observatories. From 1960s, okay, and with those objectives in mind, ESO has chosen one of the best places on the planet for astronomical observation, the Atacama Desert in Chile. During this period, Chile started several site exploration in order to attract international observatories, such ESO, to our country. As a result, Chile offered its territory, and ESO did choose the more suitable areas. The mission of ESO is to design, build, and operate astronomical observatories. Why is this? To enable important scientific discoveries and incentivize the promotion and cooperation in the astronomy fields. Well, right now I want to show you what are these sites in Chile. See, we can have this, we can see here, we can see the Chagnator Plateau, for example, site of ALMA, the Atacama Large Millimetric Array, and APEX radio telescope. ESO is part of these places for radio astronomy, alongside other international partners. Additionally, south of Atacama Desert, at 2,400 meters above the sea level, we have La Silla Observatory. Okay, this is in the Coquimbo region in Chile, where I am right now. I am in the Coquimbo region. So hello from here. This observatory, this ESO observatory, is the home of the several telescopes, such as the NTT or the 3.6-meter ESO telescope. And this one is using the HARPS instrument, an exoplanet hunter. Don't worry, we will talk about all these, maybe for some of you, strange words, scientific words. Finally, let me tell you that we have the place of our visit today is Paranal Observatory. This is an ESO observatory. It's the home of the very large telescope, the VLT, the most advanced visible light telescope of the planet. In the next few years, we will also have the extremely large telescope, or ELT, the biggest visible light telescope on Earth. Also, the CTA will be an array of telescopes focused on capturing gamma rays. Again, don't worry, get ready your questions because we will answer all your questions about all this telescope that you will visit today. Well, now we want to take you to Paranal. So that's why we will fly over to go to Paranal. Here we are. We are flying over Paranal virtually, of course. You're flying over the Atacama Desert in the north of Chile, about 1,600 kilometers north of the capital, Santiago. About 130 kilometers south of Antofagasta, the regional capital, and about 90 kilometers north of Chaltal, the closest city. Now we are going toward to the mountain top of Cerro Paranal, located at 2,600 meters above the sea level. This mountain belongs to the coastal range, and its altitude is just at 12 kilometers from the coast. Okay, here we're getting close to the Paranal Mountains, and you can see far away there in the horizon some clouds. These clouds are below the Pacific Ocean. Why this cloud? It's right there because the sky is very clear. What's happened is that we have a phenomenon. It's called thermal inversion. So that means that all those clouds that you see over the ocean in the back part of the image of the video, what you have there is the ocean, but it's covered by the clouds. And the clouds stay there. They don't go over 1,000 meters. And Paranal, of course, is at 2,600 meters above the sea level. And that reason is that give us about 300 clear nights per year. Can you imagine that? Well, I think we will get a little closer to Paranal. So you can see that this is not an ordinary mountain. Here you can see the telescope in this video, the VLT telescope, and the four ATS telescope. We will go in further. We will go to visit them in detail later on. As you can see, we have here 4 telescopes. These 4 telescopes have an 8-meter telescope in each mirror in each one of them. So, all right. So I think we're going to take a closer look. We're going to walk in this 360 degrees screen. So we will change to the 360 degrees screen now. Here we are. All right. Let me show you we are at the top of the mountain of Paranal Mountain. Let me give you a little view of where we are. You can see here in this 360 degrees view of the desert, the Atacama Desert, which is the driest desert in the world. How amazing it is. Okay, remember we're at 2,600 meters above the sea. We are looking to the east now, okay? And here we are at the platform. Okay. Before we start, I don't know if we have any questions for Eleonora.
Hello, Hernan. How are you today?
Hello, very well. Thank you. How are you, Farid? I think there is already a couple questions.
Yeah, so at this moment, Hernan, I think we have some initial questions for our guest today, Eleonora Sani. Hello, Eleonora.
Hi.
Hi, Eleonora. Well, we have a question here, for example, from Kitty Timan. Is asking, do the Elon Musk satellites influence the currents in galactic sense? I think the question, the general question should be something like if the Starlink satellites are affecting in some way the astronomical observations in general, because it's a hot topic in astronomy, not only for Paranal, maybe.
Exactly. Of course, it is a hot topic, and the answer is, in general, yes, though it depends on the kind of observation we are performing. It depends in which kind of light we are also observing, if optical, if infrared, if submillimeter, and so on and so forth. The observations that are mostly affected are observation of astronomical objects that are varying. Because if an object is varying and is varying fast, and a track of a Starlink satellite affects the image, then the variability cannot be correctly assessed. The other possibility, the other condition under which Starlink tracks registered in the images affect are the big field of view of certain instruments. If the field of view we are observing is pretty wide and there are a lot of tracks in it, or the observations are deep, then it's hard to remove the artifacts generated by this track. So basically the image has to be thrown away. Not all the scientific cases, though, are affected. Those using, for example, a small field of view are almost untouched, which is the majority, I'd say, of the instruments in the case of Paranal.
Okay, Eleonora, thank you so much for your complete answer. And we have another question here from Kaushik Bhattacharjee. This person is asking, what about the progress of the 39.3 meter telescope construction, the ELT? Do you have any news about that?
Yeah, sure. So it's proceeding, though, of course, the pandemic stopped temporarily the build of the dome. Anyhow, even with this delay, we hope to be on sky with, let's say, technical first light in 2026, and 1 year later with the scientific instruments, 2027. That is more or less the timeline we do have right now. So it will come shortly and will be amazing.
Yeah, of course, it will be amazing. Okay, Eleonora, thank you so much. We have a question here from the Chile Pavilion. In this case, the question is, what are the best weather conditions for observations?
Okay, so this is also the reason why we do build telescope in the desert. We do build telescopes at high altitude. As Hernan mentioned, we need, since these machines are relatively expensive, we need to use them as much as possible. So we need a place where it's not raining that much. Okay, indeed, we do lose observing time because of rain, because of bad weather in general, clouds, not necessarily rain. Rain, it's pretty rare, but anyhow, clouds are, of course, affecting our observation. So for 10% maximum per year of the time, so we do have 300 nights per year of clear sky. In addition to clear sky, we need for several instruments low humidity, especially if we are observing at long wavelength in what is called infrared, far infrared, and we need a stable atmosphere. We need the movement of the hair to be, we say, laminar, so let's say to follow the profile of the mountain. If the turbulence of the atmosphere is high, then this is kind of spreading the light and affecting the quality of our images. The more laminar is the movement of the atmosphere, the best it is. And this is another reason why we do put telescopes on the top of mountains, sometimes on the top of volcanoes. And we need also, sorry, let me add just one thing. We need also to be far by cities because of the light. Light pollutions also affect our images. We are so sensible, for example, that if we do need to move on the mountain with our cars at night, for whatever reason, we need to travel with low lights. At very low speed, of course, for safety, but we cannot switch on fully the lights of the car because this will affect our images, which also gives you an idea of how sensitive we are.
Wow, thank you, Eleonora. We have already so many questions, and I know that we're having this answer, but we would like to continue a little bit further in our tour. So we will answer your, please keep sending questions. We will answer those questions while we're advanced, while we're walking around the Paranal Observatory.
Yes, of course. In a few moments, I will come back with new questions, so don't worry about that. And all the people watching this tour, please go ahead with your questions, especially all the people in Expo 2020 in Dubai. Okay, Anand, please go ahead.
Thank you, everybody. Well, first of all, let you know again that these are the four UTs, so the four telescope in Paranal. We have Antu, Kujen, Melipal, and Jepun, with the Mapudungun language from the inhabitant of original inhabitant of Chile in the central and south of Chile. And also we have those, each of these telescope has an 8.2 meter mirror in diameter, okay? They're the same outside and inside. We will go inside of one of them so you can have a look. But before that, I also want to show you, maybe you wonder what these little telescope are. Well, we call them auxiliary telescope, or ATs. Okay, they're very special. They can move in this railroad that you can see here, and they have different position that the astronomer can change during the day to observe in the night. We have 4 of them, and they do interferometry. Interferometry means that you can use 2 or more telescopes, look into the same, watching the same object, the same star, and produce a virtual mirror. I think it will be better if we see a video about this, so you will have a better idea of what we're talking about. Do we have the video? Farid, please. Here we are. You're looking to this video where you can see how the 4 big telescope, when you use the 4 big telescope, look into the same star, plus the two small one, or 80s, you are able to produce a virtual mirror of 200 meters in diameter. How? Well, the light, as you see in the video, goes underneath the ground in this tunnel we call delay tunnels, to take the light of each telescope to just one point, okay, to the center point. As you see in the center of the platform, we have a building, it's the interferometry building. That's why we use that. Well, we're back, and don't worry, we will have some more questions in a few minutes with Eleonora. But now I want to invite you inside of one telescope, so you will be able to see what this amazing telescope. Here we are. As you can see, it's a huge telescope. Let me give you a little. I hope you don't get dizzy with this, but I will go around in order to show you. This is the dome, or the enclosure, we call it now. And here we are with the telescope. All the white part is the telescope. And of course, we have some people working inside of the dome. Well, they're engineer. The engineer, of course, work in the day in order to keep everything right for the night. And nobody works at night inside of the telescope. However, let me tell you how this exceptional telescope works during the night. Well, first of all, we need to we need to tell you that the main part of the heart of the telescope is the mirror, is the main mirror. Here we are. That's the mirror. This mirror in this case is 8.2 meters in diameter, only 17 centimeters thick, and it's curved. So we have, that's the main mirror, and the secondary mirror is up here, over there. Okay, and we also have a third mirror right in the center. How this works? First of all, in order to observe watching the star at night, we need to open a window. Okay, we need to open this enclosure, and we have a sliding door. Let me show you to you. Oops, too much. Here we are. All this part, this white part that you see here, these are the curtain. And behind the curtain, we have, as you in your house, your window, you have a curtain when you have to remove the curtain. But this case, this white curtain is not a curtain, but it's a wind chill. In order to not let the chill, if there's too much wind, we will stop this wind with the chill, so the telescope will not vibrate. So we open the sliding door. The sliding door go up to the middle of the top of the dome. So in the night, we will have all that open, and the light will go inside. The light will go first to the main mirror. Okay, the main mirror has a curve, a little curve, and that will reflect the light from the main mirror to the secondary mirror up here. Okay, and from the secondary mirror, we'll go back. Okay, and we'll go through the center of the mirror, because the mirror has a hole in the middle, and we'll go down where there is an instrument who capture the light and send the data, the information, to the computer room where the astronomer work every night. Okay, but in this case, we have a third mirror. We cannot see it here right now. It's right in the center. But when the lights come back, the astronomer can also send the light to the right or to the left, to the sides, I mean. Here, for example, we say Vimus. Why we send the light to the sides? Because in the side we have the instrument. Vimus is an instrument. An instrument is a digital camera. Okay, very similar, works very similar to your camera, the camera that we have even in our cellular, in our mobiles. However, of course, these cameras, these instruments are a high technology, and they can not only see light, I mean visible light, but also other type of light like infrared or ultraviolet light. Okay, so let me take you very quickly to the bottom of the telescope. Here we are underneath the telescope, and we are underneath the mirror. Okay, remember the mirror is up there, and here we are in what we call the mirror cell. Okay, well, this is what is so important, is because if you can see these boxes, what these boxes are actuators. What are the actuators? Actuators are like piston that push up the mirror in order to keep the surface always perfect. That is a new technology that is called active optic. The mirror is active. The mirror change sometime in the night because the change of temperature or the movement of the telescope. And that's why we have these pistons, this actuator that push up the mirror in order to keep always the surface perfect. So we will, in that way, we have a much better image. And here, let me show you another symphony, which is another instrument who get the lights and send the light from here, or the information, to the control room. All right, let's go back to the top of the third floor here, where our friends are working here, and maybe Eleonora can answer some more questions, but I'm sure there is a lot of questions for her. Hello?
Yes, Hernan. We have another question here from the pavilion in the Expo 2020. For example, here is a question from a Chilean musician in Dubai. This person is explaining that that because he makes pop music with the space sounds from the Orion Nebula, how possible do you think it will be to present live shows at ESO observatories? So, Eleonora, do you have some information about that?
Yeah, sure. Okay. So at ESO, we are very interested in expressing science through art in general, and the synergy that art and science can create. And music, of course, is one of these. We had, for example, Brian May and Yo-Yo Ma visiting us in the past years. They also gave concert there. It was just amazing. And we have also a program, for example, together with Switzerland. So it is definitely possible. Right now, we cannot have visitors in Paranal because of safety due to the pandemic restrictions. We are retaking full personnel exactly in these days, in this period. So hopefully, in the next few months, we will be able to host external guests again. Cannot claim anything about this. It's just a very personal hope. But if you're interested in submitting your ideas in your project, please visit our outreach pages on the webpage. There is the email, the contact to send your ideas, your project, and it will be considered for sure.
Okay, Eleonora, thank you so much. So just because you mentioned this project with Switzerland, I am sharing with the audience a link about that. So any people can visit this and take the information about that. Okay, we are still waiting for more questions from the pavilion. But we have a question here from the general audience. For example, Daniel Jorn Malesani is asking, are you having any visiting astronomers these days, or it's entirely done in service mode by the staff? Will it change in the next months?
So no, we are still under kind of restricted operations. So we are starting to have full personnel in the next few weeks. We are restoring normal shifts basically now. So there is no certain date yet to have visitors back for their scientific observations. And so we are running all in service and in what it is called delegated visitor mode. So the astronomer who is visiting is remotely connected together with us. And I'm not sure I got correctly the name, Daniele, in case. Hi.
Yeah, maybe it's someone who knows you.
Yeah.
Yeah, exactly. Okay, thank you very much, Eleonora, for your answer. We have one last question, I think, for this stop for questions. A person is asking, are these telescopes able to analyze eventual atmospheres of exoplanets?
Yes, it is possible. So it depends, of course, on the brightness of the object we are observing. Studying in detail atmosphere of exoplanets, so planets that don't belong to our solar system but that orbits another star is one of the main goals of the next telescope, the extremely large telescope, about 40 meters wide, the primary mirror. But it is already possible with our instruments at Paranal, and papers have been published in the last few years, 2-3 years. There are instruments that are particularly dedicated to this. So let's say, since the sources are very faint, the analysis of the data is quite complicated. It's not easy, but yes, it's possible. And the atmosphere of a planet is basically observed once the planet passes in front of its star and filters the light that is coming from the star. So one can compare the light of the star when the planet is not passing in front of it, and subtract such signal from what we do observe when the planet is passing in front. And from this, one can obtain specific parameters of the planet, like the composition of the atmosphere, or at least have some hint, some particular element that is in the atmosphere. A complete analysis like what we can do within our solar system is yet not really possible because of the faintness of the target. And as I said, is a goal of the next generation of telescopes.
Okay, Eleonora, thank you so much for your answer, and thanks again to all people watching the very interesting tour, especially to all people in the Expo 2020 Dubai. So we are still waiting for your questions. So please keep sending your questions because we have more time for questions in a next opportunity. Okay, Elan, I think we can continue now with the tour, please. Thank you.
All right, we will continue with the tour, and remember you that that from here the telescope will take the information, will take the light, and go to the instrument, and from the instrument the data will go to the control room. So I want to invite you to the control room where the astronomer works, where Eleonora works every night, and here we have to get out to the platform and walk about 100 meters and go to this building here where we have the control room. Here you can see the control room from a little bit far away, and now we will go to the control room inside. Here we are. Again, of course, here is where the astronomer work every night. Okay, we have, as you can see, 4 different rooms, one for each UT, or for each telescope. As you see here, we have the UT4 that people are working right here, right now, and they work every day. Even in the day, there's day shift and night shift. And here we are in the UT3 or Melipao, the telescope that we just visit. Okay, from here the main operation is made by the telescope operator at night. He's an engineer who is controlling the telescope and sending the telescope to anywhere in the universe. And of course, the astronomer work here, and it's where they receive the scientific data, and the astronomer makes sure that is the one that he needs for his or her research. Let's see. I think that I will invite Eleonora to tell us a little bit more about how is the job of an astronomer at night in this control room.
Yeah, so the nighttime crew reaches the control room at sunset. Okay, and once there, we do receive an handover from the daytime crew, which tell us about the status of the instruments, if everything is working correctly or there is some issues, something to follow up. We do also get all the inputs for the night. For example, if there are, if we do receive some time critical observations, something to be urgently observed, and we do start the night taking calibrations. Basically, during the twilight, we might need to take specific images to calibrate the instruments. And then what we do is to prepare a schedule. So we have a series of observations that can be done during that night, and we do match what can be done with the current conditions that we do have: the transparency of the sky, the turbulence of the atmosphere, the amount of moon illumination we do have, humidity, for example, and so on. And so from this match, we do decide what to observe. And during the observations, we monitor what is happening. In case of issues, we of course do. We might need to stop the observation, fix what is going on, and restore the observations. And once the observation is completed, we let's say do a quick analysis of the data and assess the quality of the data. Do they actually match the conditions requested by the user? If so, we do certify the data as very good, and we move on with the next observations. Actually, the analysis is done when the next observation is already starting to be efficient. But okay, that's a detail. And yeah, we continue like this for the entire night till sunrise. Yes.
Well, thank you. Well, we right now how hard this the astronomer work at night. I guess the winter are long nights, isn't it?
Exactly. In winter, it's harder for sure. Can be up to 13, 14 hours of work.
Yeah.
But we enjoy it. It's amazing.
Great.
Anyhow. Mm-hmm.
Great, this, especially with this amazing sky. There is any question for Eleonora Farid in this stop?
Yes, and then we have a couple of questions at this moment. For example, Andy Huxtable is asking, what is the oldest or strangest thing you have observed using any of the telescopes you run? So maybe you can tell us a personal experience, Eleonora, about your work or this kind of stuff.
Sure. So what I do like of being an astronomer at Paranal, given the heterogeneity of instruments we do have, is the fact that we can observe many different scientific cases, from asteroids from our solar system up to the deepest sky, farthest object. When the universe was just a baby, we can observe the kind of first galaxies in the universe. So there is a huge amount of different scientific topic we can go through, and this is extremely fascinating and interesting. There have been exciting observations for sure in these years. Of course, I could not take part to everything because we do work in shifts, what we do call turnos in Spanish. So we are not always up on the mountain observing, but among those that I observed or took part somehow, there was in 2017 the first kilonova ever observed in history. So it is a clash of two neutron stars, we think, which was supposed to happen by theory, okay, but was never observed before. And it was extremely exciting, and these observations also led to demonstrate how heavy elements, heavy metals like gold, are produced in the universe. So this was really something unique I could take part of. Another experience was the observation, which is repeated in time, of stars that orbits around the supermassive black hole at the center of our Milky Way, which have been done with several instruments. The most recent one is gravity, which is mounted at the interferometer. And this series of observations over almost 20 years in the end brought the Nobel Prize the past year, the Nobel Prize in Physics 2020. 1/3 of the prize was thanks to our facilities and recognized to Professor Rainer Genzel. Yeah. So pretty interesting, pretty unique as a job.
Yeah, of course, Eleonora. Thank you so much for sharing your experience. And we have one last question at this moment. It's a short question, but it's very complex. John McColpin is asking, how hard is it to find intelligent life?
Oh, that is 1 billion euros question. Indeed, how hard it is. Well, how can I say? Thinking of being alone in the universe is maybe pretentious, a bit sad. Personally, would be nice to have someone else. But finding signs of life is extremely difficult, both in terms of probability, okay, because maybe we are not just overlapping in time with other intelligent populations in the universe. Maybe someone existed, is not existing anymore. And anyhow, the signals are coming to us with a certain delay given by the distance, okay? So first of all, it's difficult to have other forms of life. And finding the signature, how we can find the signature? We can find the signature. So for example, we assume that other forms of life are kind of similar to us, so that you do need water, a rocky planet, some atmosphere, okay? So to develop, so we search for small planets, size of the Earth, Mars, something like that, with an atmosphere. But as we said before, already analyzing an atmosphere in exoplanets is not trivial at all with the current technology, okay? Then we might look for carbon in the atmosphere, because just because we do breathe, we do produce carbon monoxide, so we search for it. But again, finding these signals is not easy, and especially it's not easy to disentangle what could be produced by life and what could be produced by other processes like volcanoes in a planet, no? So to be able to find actual signature of life, we do need to go deeper. Intelligent life, then it's even more difficult, right? The probabilities to have it and to find it's even lower. For intelligent life, anyhow, we do need to find signals, basically light signals, that cannot be explained by natural processes. Up to now, this didn't happen. Let's see if we do get something in the future. Maybe we don't have sensitive instrumentation enough yet. That might be. But we haven't found.
Okay, Eleonora, thank you so much for your answer. Of course, this is a very complex question.
It is.
And okay, before continuing, Nan, we have a question here from the pavilion in the Expo Dubai. This is the question regarding the data collected at the observatory. Is it open for people to use it and eventually collaborate?
All right. So this depends on the observatory indeed. Every institution has a policy about the data. And in the case of ESO, the data are proprietary data for 1 year. So as a scientist, if I do want to observe with our facilities, I submit the project, I got the time, data are collected, and are mine and only mine for 1 year. And if someone wants to give a look or know what the data can say, has to contact the principal investigator of such project. After 1 year, such data are released publicly and are available in our archive. Whoever that as a user, let's say registered in the ESO archive, can download such data and analyze independently. There are also special programs that are called public surveys, okay? And by definition, being public and approved by the institutes, the data are released immediately. We do also release, okay, it takes a bit of time, of course, to process the data, but beyond what are called raw data, so what comes from the telescope, we do provide data sets that are reduced, so to facilitate then the analysis. And of course, collaboration is always welcome in science. You just need to contact who you're interested with to collaborate. And scientists also collaborate for various projects, also with amateurs, with non-professional. Amateurs are great, for example, in the monitoring asteroids, in monitoring and spotting supernovae, and so on and so forth. That's great. Science has to be open.
Okay, Eleonora, thank you so much for your complete answer again. And okay, and I think we can continue now with the tour, and after we can continue with more questions in case we have more questions. Thank you.
All right. So, okay. Well, today we're going to be able to do something that we don't do. I remind you that whenever we finish, we will have in full operation in the observatory, we will be able to have our visit, our Saturday visit. So you will be able to come to Chile and visit us and take this this tour by your own. But that's a tour are in the day. And now, thanks to technology, and thank God, we are going to show you this amazing sky at night. So I want to give you a little tour of the Chilean sky, the southern sky at night. Well, in this picture, we can see that the sunset just set and the night is coming. The telescopes are open, but not observing. They are against the sun. So they're waiting for the total night, the total darkness, in order to start observing. And we can see in this picture some amazing constellation. First of all, let me show you here. We have what we call the Orion constellation, which is a northern constellation. However, we can see it from Paranal, but upside down. Okay, if you don't see Orion constellation here, I mean, if you don't see the warrior, because Orion is a warrior. Let me help you a little bit. Here we have what we call the Orion belt, okay? And here we have one leg of Orion, another leg here, and here we have one arm and shoulder, excuse me, and another shoulder. An arm is here, and over here we have what we call the shield of Orion. The head will be here. So this is the Orion, the Orion constellation, and because the picture is spectacular, and also the sky is amazing, we can see also what we call the sword of Orion, which is the Orion Nebula. Okay, remember, this is a picture was taken by a camera, a regular professional camera, but it's a camera, and here we have the Orion Nebula. The Orion Nebula is where thousands of stars are burning right now. So there we have Orion, and maybe some of you can recognize something that we have down here, which are the Pleiades. Okay? The Pleiades, or Subaru in Japanese. Okay, here we are. This is an open cluster. Very, very new or very young stars are here. Okay, they are just born. They have only about 100,000 years old. Very young for us in astronomy time. And of course, here we have something that maybe many of you could recognize, which is the Taurus constellation. Okay, and as you know, because the Greek myth, Orion is fighting against the Taurus. This is one of the horn of the Taurus. This is another one, and is fighting against our hero is fighting against the Taurus because he wants to get to the Pleiades, where his love is, Alcyone. This is a little bit of Greek mythology. And up here we have the dog, okay, the big dog, or what here we can see, which is the best friend of Orion. Here we have the eye of the dog, the back, the tail, one leg, another leg. See, that is how we, the Western people, used to look to the sky. But let me show you something that you, if you are in the Northern Hemisphere, are not able to look if you don't cross the equator. But if you do, and if you come to the Chilean desert, the Atacama Desert, the driest desert in the world, you will have this amazing view. First of all, what we can see here is what you have at your right. These are the Magallanes Cloud, the two Magallanes Cloud, the large Magallanes Cloud and the small Magallanes Cloud, okay? And also, here we have the Southern Cross. And a little bit down here, we will have Alpha and Beta Centaurus, okay? Just one tip, before we go back to the telescopes. If you are in the south, and if you're especially in Chile, in Atacama, and you get lost, don't worry, because I will let you know how to find the south, how to find the south in order you can find your way back to your home. If you take, for example, these two Magallanes cloud and you make a triangle, okay, in this angle of the triangle, just in the center here, you will find the southern celestial pole. The southern celestial pole is showing you the south. We don't have any, as you see in the picture, we don't have any bright star like you do in the northern hemisphere, which is the polar star. Well, we don't have a southern star here, but we can do this triangle with the Magallanes cloud and find the south. Also, you can use the Southern Cross right here. Okay, this is the Southern Cross, and you take the longest stick and go 1, 2, 3.5 times, and you will be also in the southern celestial pole. Okay, so that's the easy way to find your way in the southern hemisphere. One last thing, also let you know that our people, our inhabitants, the original people of America and Latin America, they used to have their own constellation, for example. But because this gorgeous sky, no light pollution in 2,000 years ago, they have this. They could see the Milky Way, which is this path of stars here that you can see in the sky. All this is the Milky Way, and they could see this dark spot in the Milky Way as constellation. For example, here you can see a head of the Llama. The Llama is the biggest constellation for them, and here we have what we call the cool sack. We call the cool sack, but for them used to be a bird. Okay. Also, they have a small llama and all other animals of their daily life in the sky in this constellation or Andes constellation. Well, I think the time is passing by very quickly. I hope you joined this tour in the southern sky, but we need to go back to the telescope, and especially we will go back to show you a very special place. We will go down from the platform and we will walk down. We're at 2,600 meters above the sea right now in the telescope platform, but we will go down to 2,400 meters, where is the Paranal basic camp. Okay, here we have the camp, but let me invite you to a Residencia tour. This place is where the people that work at Paranal take a rest, eat, etc., and where of course they sleep. It's a very special place. We're here inside. As you see, we can see green. Finally, we see green. We have some water. This is pool, and here was people come and has his room to sleep. And of course, also we have a dining room. This is the lobby of the Residencia, and here's the cafeteria. And it's where people come after they work to take a rest, to sleep, and have something to eat. So let me tell you a little bit about the dome here. And very important to show you, you see in the center of the dome, we have here a carpet. We have to close the dome in the night to not let any light to go outside. It's very important to not produce light pollution in the telescope, in the observatories, but also our country, Chile, has a special law in the three main regions where the telescope are, where the observatory are, and we are trying to keep the light down. And it's very easy to just put the light down and not to the sky, to preserve this beautiful sky that you already saw, and not only for Chileans, but the whole humanity. So we're about to finish the tour, but I'm sure that we have some more questions, final question for Eleonora.
Yes, Hernan, we have one last question, I think, from the people from the Chile pavilion at the Expo 2020 Dubai. So in this case, Eleonora, the question is, what is the impact of climate change for the space observation? Is the energy used for observation green and or sustainable?
All right. So the impact we have because of climate change is I mean, we can perceive it. It's clear. Because of climate change, we have more cloudy nights. Okay. Because of climate change, we have more extreme events of strong wind, for example. Like, I can make an example. 3 weeks ago, we had 110 kilometer per hour wind, and our control building was literally shaking all the day. It was a constant quake, okay, because of the wind. And these events, like 10 years ago, were not really happening, not with this frequency. So climate change can be perceived also through our work. Which is our impact in terms of sustainability of our observatories? Well, this has always been one of the environment. In terms of shape, in terms of colors, you can barely see it. It's underground partially, and all the colors are the same colors of the desert, basically. Of course, not everything is possible with big telescopes. You cannot put those underground. And also in terms of prints that we do leave in the environment, we try to recycle as much as possible. And we are working to be greener and greener, let's say. So, for example, we were used to have generators, diesel generators to produce electricity, but now the entire observatory is attached to the electric lines in Chile. So this, of course, is greener. Also in terms of transportation, we are trying to do our best. We have electric cars now, for example, in Paranal. So it's work in progress, of course. As technology evolves, so we do try to follow technology as well to be green.
Okay, Eleonora, thank you so much for your answer. I think we don't have more questions here. I don't know, Eleonora, if you want to say, I don't know, some final words about your personal experience in Paranal, because it's a wonderful place. I don't know if there is something that maybe it was more impressive for you when you arrived to Paranal working as an astronomer. I don't know, something to share in your experience.
So doing this job, okay, I decided to be an astronomer because basically I'm curious. I want to understand how things work, okay? And studying astronomy allows to include all the possible physics you might think about: nuclear physics, physics of emitting processes, gravitation, general relativity, special relativity, and so on and so forth. And being in Paranal is like, I mean, it's like entering Notre Dame. I mean, it's like entering the most amazing technological place to do this kind of science, this kind of research. The kind of technology we do have in Paranal is unique. All the instruments are basically prototype. And while working there, you feel like you are a Formula One pilot. You are super specialized. You are one of the few people of the work being able, having the knowledge and the skills to manage such instrumentation. That is really something unique. It's a challenge, of course, sometimes, but it's an experience that definitely is worth to, if you are an astronomer.
Yes, of course, Eleonora. It was a last question a few months ago regarding the black hole recently observed, and it was a question about if we are able to have more information with these telescopes. I suppose regarding black holes. Maybe you can give us some short approach about this discovery of the black hole with the ESO facilities.
Yeah, sure. So With ESO telescopes, one can do sorry, two things: search for black holes that are not yet known, okay, and study in detail black holes that are already known. Now, I'm not sure what referring to with recent discovery of a black hole, but what we can do is to observe black holes in two ways, basically. One, observing the orbits, what do stars do if there is some star close to a black hole and it's orbiting it. And this is the case, for example, the galactic center. And with that, what it has been done recently is to study relativistic effects, so the star orbiting these black holes are proceeding exactly in a similar way as does Mercury around our sun, with a component in the movement that can be explained only through general relativity. And that has been observed in the case of a supermassive black hole at the center of the Milky Way, is one of the observations that led to the Nobel Prize. What we are missing right now is, for example, to measure how fast this supermassive black hole rotate. And this is doable in few cases in an indirect way, very complicated analysis of the data, but with what we are building at Paranal, it will be possible. We are provided all the telescope with laser facilities to produce artificial stars, and this allows to remove those artifacts generated in the image by the turbulence of the atmosphere. Doing this for all the telescopes and observing the same black hole at the same time will allow us, we hope, to measure the rotation speed of a black hole. The other way we can observe a supermassive black hole is while this is active, while the black hole is accreting gas on it. And I mean, black holes can be greedy, okay, and eat a lot of gas. And when this is happening, the gas reaches very high temperatures, very high velocities, very high temperatures, and emits light. And the signal of this light emission, it's very, very typical, and we can study it and measure, for example, how big the black hole is. And they can
Okay. Okay, Eleonora, thank you so much for all your answers. I know you are an expert on black holes, so thank you for translating. Thank you for translating all this complex information into friendly words. And yes, I think we are ready with the questions. We are ready with the tour. So, Nan, I think we are ready to finish. And from my side, I want to say a big thank you to all the people from the pavilion, the Chile pavilion in the Expo 2020 in Dubai. So please, Nan, I think we can go and finish this experience.
Yes, of course, with this screen, with this picture of the sky, of southern sky, we want to say goodbye. We want to thank you very much to everyone in the Expo 2020 Dubai, and of course to Eleonora Sani, our guest astronomer today, who answered all your questions, especially the last one, which is she's an expert in black holes, and of course también Emilio Girardin, who is in Dubai right now, and thank you for all the connection, and to Farid, also that was our producer for today. Thank you again. Remember you that we have a very, very good website, the ESO.org. You will find all the information, all, I would say, thousands of pictures and thousands of videos about the universe, all the research that Eleonora and all the astronomers are doing here. So please go and visit that in ESO.org, and also in our Facebook page, which is ESO Astronomy in English and ESO Chile in Español. So we will be waiting for you in our webpage, in our in Facebook, in all our social media. So thank you again very much. Thank you, Eleonora. Thank you, Emilio and Farid. I hope to see you very soon, everybody, every one of you, in the next days. Bye bye.
Bye bye.
Bye
To
bye.
everybody.
Bye.